Okay, so in this problem, they're asking us to form a solid by rotating this line about the x-axis. So if this is the x-axis, this is the y-axis, the line square root of x, y equals square root of x, looks something like this. And if we assume this is x equals 9, x equals 9, right there. So we're going to rotate about this point, about this line, sorry. So we're going to rotate it. And what we get at the end is something like this. It's going to look like a cone, right? Where the x-axis is this one passing right through the center of the shape. And the key to any of these problems is to break the solids into little tiny disks. So if you can imagine just breaking it up into disks, all these are disks. Okay, so the reason why we want to do that is because we know the volume of a cylinder, which is what we have in this case. So the volume of this cylinder, pretend that's a cylinder, right? So maybe let me draw a little bigger. So this is a cylinder, right? It's almost, think of it like a coin, right? And then the thickness of the coin is the height of the cylinder. So that's the height. And we have some radius. Okay, that's the radius. Okay, well, looks like a Y, but it's radius, okay? Radius. Okay, so the volume of a cylinder, it's pi r squared multiplied by the height, which is h. In this case, our radius is given by y. Because if you can imagine, so right here we have our little, our disk. So this is the thickness, that's h. And then the height is r. So the height will be this. That's r. Okay, so r equals y. And h, that's going to be dx. All right, so then we have dv. So an infinitesimal volume, like I said, the key to these problems is to break the solids into really tiny coins or disks. Okay, so then the volume, the infinitesimal volume is going to be dv equals pi y squared this is kind of difficult. Y squared times dx. Right, notice what I did is I just plugged in the value for r and the value for h. Okay, so then the volume is equal to the integral from a to b, from a to b of the infinitesimal volume. Okay, so in this case we have the integral from 0 to 9 from 0 to 9 of pi y squared dx. Okay, so where y is our expression, square root of x. So therefore, when we plug it in, we will get the integral from 0 to 9 of pi square root of x squared squared dx. So when we solve for this, this is just a simple integral. When we solve for this, we're going to get, I'm out of time, so that's why you just have to do this. We're going to get pi over 2 x squared x squared from 0 to 9. And when you evaluate the expression, what you get at the end, this is the volume is 81 pi over 2.